Hello and welcome back to Having Fun Repairs. This is part 2 video series where I attempt to repair some Tamagotchi style toys. I feel like I'm a little bit better off after that first video and first attempted repair, having somewhat built a circuit diagram for these things. But for now, I'm going to move to these three. Now, oddly enough, this is another one very similar to this guy here. And whereas the previous one just said made in China, this one actually has a stamp on the back, 1997 MGA Entertainment, all rights reserved, made in China. I still couldn't find any diagrams for this online. And I actually was looking up these as well to see if I could find any direct circuit diagrams. So this one right here, I think is going to be pretty similar. These might be different. If they're different, I'm probably going to try to reverse engineer as much as possible these right here and compare with this diagram to see if there's any difference. But I don't suspect there to be too much difference on those. Yeah, what do I know? But I think that's enough waffling. So let's what issue did we have with this one? Let's see, TaTa Puppy. TaTa Puppy was the first one we tested. The power's on and it has sound. The buttons work, but it needs to be cleaned. Okay, so this one's going to be fairly easy. This one's primarily just cleaning. So without further ado, we will get this one cleaned up. So I want to stop for a second and compare the previous one to this one. I'm noticing some differences as design differences that I think are actually substantially better. Whereas the previous one, the circuit board was mounted to the chassis via 2 screws on the left, and then the back side you had your 4 screws in the same style configuration. This one is using a screw in top and bottom, and I think that's better, at least from what I was working on with the previous one, because it allows the upper portion of this board to draw closer to the LCD. I think it provides better tension to these elastomeric strips or connectors on there. Truth here. It turned out pretty okay. Just a clean. Would have been great if the other one didn't have the screen issue that it did, but you know, it's just kind of boring if I'm being honest. Just cleaning it off and putting some batteries in it. But it's good to go. It's got a little doggy on there. Got different modes. I guess you can change the time and dates. Yeah. Got a little dog there, but I'd say that's pretty cool. So 1 down, 2 more to go. Alright, so next we have this RA or BA RV, RARV T Rex Don't know. Pretty sure you can find it online. RARV T-Rex is the one I'm going with. Made by Tiger Electronics. It's a Gigapets. Looks like it came out around the time Jurassic Park: The Lost World did. You can see that little tag down there in the bottom right hand corner. Oh gas. There we go. Well, it should date the product for you. Let's see. On the back, 1997 Tiger Electronics. And what was the issue that we had with this device? Let's see. I wrote down RARV T-Rex. So it wouldn't power up, so we can't really test if the buttons work, if they're sound, and then cleaning. Obviously, I cleaned a little bit off the screen, off camera, wiped it down a bit. You can still see there's quite a bit of dirt in the corners. So we'll definitely give it once over with an alcohol rub. But we need to figure out why this thing is not powering on. So I'm going to take off the case and hook it up to the power supply. I think that's the first thing we'll do. Okay, just with the back cover off, I think I found the problem. Now this thing is nasty. It is super grubby. There is quite a bit of corrosion, either from battery leaking, maybe this thing got dumped in the water. Circuit board, PCB is not looking too well either. Screws look to have some mild corrosion on it. The board itself does. Pads have a little bit of corrosion on it. And nothing that's not cleanable or fixable so far. Even this right here I could pop out and clean. But, you know, at least with what I'm seeing, is that cap okay? Cap's got some kind of goop on it. It's fairly elastic, so I'm wondering if that was some type of glue. I mean, it looks like it might have been, because you got the same nonsense on the other side, almost like a very strong rubber cement. So the first thing I'm going to do is strip back these wires a little bit and hook it up to my bench power supply. And this looks like it's going to be the positive rail. This one will be the negative. See, that's connected to this side here. So this is saying positive up for both sides. Yep, so that makes sense. Even the positive rail is fairly corroded. But positive and negative, and we'll see if it'll turn on from there. This out as best as possible. Oh, something's happening. I'll give it the full 3 volts. And we'll see what's going on with the screen. Alright. So, screen's working. Usually there's some kind of cycle going on before you can do anything. No, buddy, it's not fixed. Not yet. lead going to the negative terminal of the battery completely detached from the board from this point right here. So the entire thing powered off. I think what I'm going to have to do is just kind of map this out a bit. So looking at this, it is time to tear it down and get it extremely cleaned up and repaired. Obviously, game plan is moving forward, cleaning this PCB. I'm going to replace all these wires to where they're going to. Would you look at that? Even the speaker wires are barely holding on. This one looks like it's been crushed between the plastics. But wonder if this device is a little bit different. If so, then I'll just draw another diagram. But from here on in, it's teardown time. Board sufficiently clean. I already have a little paste flux in a couple areas. I'm going to pre-tin these wires I selected to replace the old ones and get everything resoldered onto the pad. Hindsight 2020, I wish I had worn gloves while cleaning this thing, because as I was removing the old wires, etc., especially around high corroded areas, there were some weird smells coming through. So I'm wondering if the corrosion, some of it was due to maybe this toy falling in a toilet with maybe urine in it. I mean, I don't know. The nastiness of the entire board was, how should I put it? It was just disgusting. I'll say that. But it's been cleaned off with alcohol. I'll probably use some type of polishing wheel and etc. for the plastics. There is a nice discoloration, dark discoloration over here. I don't know where that's from, but you know, at least it's been cleaned with alcohol. At least I'll just move on from here. So like I said, next is going to be pre-tinning things and soldering things back up and touching up on a couple of the solder joints on here that had corrosion, just getting fresh solder on them. I think I have things put together good enough just to do a bit of testing. So I'm going to get a few screws in and hook at least the DC power supply back up and test out the board to see what happens. Ignore that dot, that's just where I put a little mark so I knew which way was top and bottom. If that matters at all, I'm not too sure. But seems to be, yeah, I'll be cleaning that off. Seems to be working pretty good. The buttons are now working too. I don't think they were previously. All that corrosion underneath them. Let's see, food, can we enter? Can we switch the type of food? Sure, whatever that is, enter. That works. What does mode do? Alright, mode allows us to set time and date. Cool. Alright, okay, so I'm just going to clean a few more parts and button this up and probably give the plastic a little bit of a polish with the Dremel tool, and I would say this one's pretty much done too. I did want to stop for a second before buttoning this thing up and actually just go ahead and check the crystal on it. Comparing it to what we had on the previous one, it's actually 32.77 kilohertz crystal. But for the most part, things are similar, albeit different. It is not a direct layout of this, but it's a facsimile of, if I can use that term. It's very close in design. Plastic's polished up a bit. Pretty decent shine to it now. I'm going to reset this one more time. And we'll call this one good. And move on to the next one. Okay, now on to Compu Kitty. And what was the issue we had with this one? Compu Kitty, no power, thus we couldn't tell if there was sound. If the buttons functioned, it could definitely use a little bit of cleaning as well. So at this point in time, we will quickly tear it apart and take a look around it. Took it apart, and even though I said I wasn't going to do another one of these. I believe I said that. Oh, actually, sorry, these. Did anyways for the Tiger Electronic Compu kitty. Primarily because, you know, curiosity got the better of me, and I figured, why not? So, move this aside for a second. You can definitely see with a side-by-side comparison some likenesses and some differences. What was this one? This one was the what you call it, the first one we did, the generic China-made one, right? And then here goes the Compu kitty. They both have a chip on board, they both have a speaker, piezoelectric speaker, both have an LCD, both have 1, 2, 3, 4 switches, those physical buttons you press to select enter or mode or left or right. They both have a reset switch, which I term annotated as S5. Both using 3-volt battery, two what were they? 2 battery cells, 1.5-volt battery cells, whatever type those were. And I'll probably put in a little doobly-doo or a little note up here. But what were some differences? Well, this was your battery protection. Say if you put the batteries in backwards, little 1N4148 diode. You have the same thing here, except it's a little different. You have a resistor. Well, first, the S5 comes out of your cob. You have a dielectric capacitor on one side of the button, decoupling yours, I presume, from that line. And then on the other side, you tie into this rail here. And then from the top, coming from your 3 volts DC to the resistor, I labeled it R3. And then the diodes out back to the positive rail. And then these are tied together through this line. Portion of it goes off to the other side of your reset switch, and then the other side hits this big I shouldn't say really big, it's not, but it is the biggest capacitor on the board. 10 volt, around 500 microfarad capacitor. So there goes that. What else can we say? Well, the speaker is functionally different. I mean, there's a capacitor on the other speaker. This one is using an inductor on one side, and probably for suppressing noise. Then from the other side of your speaker, you hit R2, which is another resistor. This one here, tied to this little 1 alpha NPN transistor or MOSFET, one or the other, without an exact code. If I can get this to focus, can't tell you exactly what this is. Nor could I tell you if this portion of the diagram is 100% correct. Now, I believe this is a NPN transistor, and I believe you go through the resistor to the collector. Thank you, bud. And then the emitter through R1, but these could be reversed. And the more I think about this, the more likely I think it is. You would have, I want to believe the emitter would be on this side heading to the speaker. And but I could be wrong. I don't know. This might be used for managing the gain of the speaker, I want to say, driving the speaker to produce loud enough audio. Of course, the base of the transistor is going to ground. I just drew ground here instead of drawing another line going all the way down. Then you have, multiple lines heading up here going to these zebra connectors in which the LCD is fixed. You know what? I actually feel like I'm leaving something out here. I definitely am. I'm leaving out this crystal. Where's my draft at? I'll draw it in real quick. I definitely forgot to do the crystal. So you do also have I'll put the capacitors there. I just forgot the crystal. So let me draw that in real quick. A little line there, a little line there, open box here. You do have it's around 32.7 kilohertz. I'll draw bigger down here. 32.7 hertz. XTAL crystal. And then on the other side of it are some small ceramic caps. These right here, going to ground. Of course, 4 buttons down here, pinching that. Then I started looking at these diodes over here and trying to figure out the purpose of these, which I haven't quite wrapped my head around yet. They're coming from the cob. There's a line that feeds to the anode of each one of these diodes. The anode is all tied together. Cathode's down here. And then on the cathode side, you hit through hole up to these pads down here. Likewise, these pads here, the upper ones, just feed right back into the cob. So it's almost like these are actually here to the anode, out, and then back to actually here. Could do it like that. Not actually physically connect this here and there. And that might actually be more appropriate. Of course, this is making my diagram a little ugly now, but it is what it is. But these unpopulated pads, I don't really know what goes here, but maybe those are your data lines for programming whatever, programming the actual memory in here to run the little virtual pet program to begin with. So to me that would make most sense, but again, what do I know? I'll take a photo of this and put it up on the website as well for anybody to go look at and see. Now I'm going to put this back in there. I'm not going to hook up the speaker, but I'm going to inject 3 volts DC from my benchtop power supply and just see what it does from there. And if it works, then a lot of effort for just needing to clean up one little contact. But it is what it is. We learned something, hopefully. I know I learned quite a bit. So that's what I'm going to do next. you hit that short out between the reset pins. Still nothing. No, there's a little something. But you can't really see anything. Wonder if the LCD just isn't quite good enough from the zebra connectors. These are all fairly tight. Tightening them up, got more of a picture in there. So we'll say that that is it. We're missing some of our lines there. So I'm going to tighten this up a little bit more. Let's tighten this tight. It's all tight. Alright, so maybe just clean up the zebra connector a little bit, put it back in, that will do the trick. So I'll take it back apart and do that. Okay. Now I'm not sure if I did this when I was screwing things back in. I don't think I did, but it could be one of the reasons why it was not displaying all the lines or initially had the issue. This post right here is completely disintegrated. Notice when I was putting that screw in that it was just very loose and kept loosening back up. It wasn't getting tight, and I wasn't over tightening because I was checking to make sure I wasn't over tightening them as I put them down. But that post right there for the bottom right screw is completely destroyed. Now I cleaned this up with a little bit of isopropyl alcohol and dried it off. Not too sure how I'm going to repair that. Yeah, it's just falling all to pieces. There's another piece right there. It's actually cracked through this right here in its entirety. I don't know if you could see that, but all through there is cracked. So I think what I'll do is I'll throw some super glue down in here, and hopefully that will keep it from deteriorating more. Alright, so put it back together, and I was to get every single dot on this LCD liquid crystal to excite and display a perfect picture, so long as I had good pressure on this piece right here. So if you remember me pulling off a little tape, I think that's there to keep the batteries from shorting anything else or shorting to these posts. But what I did is I put a little piece of paper that I folded over a couple times underneath some tape here, because I know that's going to butt rest up against where the batteries go in, and hopefully be able to put additional pressure on this point, and it'll hopefully work. So what I'm going to do now is go ahead and kind of wipe down the inside of this one. I can put these little paper O-rings back on those batteries on the outside where I pulled them out because they weren't as grimy as the one before it. I think they're perfectly acceptable to be able to reuse. And solder everything back in and clean that little bit of corrosion off of there. Throw the batteries in and see what happens from there. So let's do that next. Moment of truth. I put these LR44 batteries in. Now I'm not going to polish this one the way I did the last one because I realized after I polished it, even though the plastics look really nice, now I'm just going to wipe it off again with a little bit of isopropyl alcohol. But when I polished up the other one with the Dremel and some plastic polish, paint came up quite a bit, and the T-Rex one, the paint coming up, I mean, it was already missing quite a bit of paint. This one right here is not, so I don't want to run into that same issue again. I'd rather not get rid of the paint that's left on here. So we'll put these batteries in and test it out. Positive side up. Screw that down. And let me hit this reset button. What do we have?
Yeah, to help you on the back line.
Okay. Nothing. Why is that?
There's nothing at all doing something? I think the cat was doing something.
Let's take the batteries out.
Daddy, I think something happened.
Yeah, something did happen. It's really weird. Let me hook my power supply back up to it. Hey, there we go. Alright. Wonder what happens as soon as I screw this back down. If it'll cut out. Nope. Still there. Sound working. Let's zoom back in. What time is it? 11:47 p.m. Name B A D. I feel like I went way too overboard on this thing. Well, left, right definitely work. Inner works. Mode button works. You just select up all the icons. So, this one is good to go, and let me hit that reset button. Apologies for the brief interruption in this video. I'm actually rendering part 2, or doing the video editing right now over on my PC for this part 2 of the video. Primarily these recordings were made late January, and here it is March, and I'm finally having the time to do the video editing and putting it together. But when I was testing these out for hoops and giggles, for while working on this video, I noticed that this right button was no longer working, or excuse me, the left button was no longer working. And if you recall, I put super glue down in here, and that was probably not the best bonding material to use, because as super glue dries, it disperses a fume, if I can put it that way. The whatever makes up the glue releases these fumes, reacts with plastics and etches them, leaves some white stuff behind. And so I had to take it apart just to get this one button working again. I was able to clean out the board, that wasn't too bad, but for the life of me I just could not get this pad, this one over here, to provide a good electrical, allow for a good electrical current through it when depressed. The residue had gotten inside that pad and made it super hard, and regardless of scraping or isopropyl alcohol bath or anything, I just couldn't get it to be electrically good again. So what I did instead is I got JB Weld 2-part epoxy where I originally put that super glue at, and put that in there, and now I can just set that screw in through this 2-part JB Weld. And then I took a smidge of it as well and put it on where this conductive pad was at, these carbon pads, and then I cut a little piece of aluminum foil and overlaid it on top of the pad, because aluminum, or as they say here in the United of Kingdoms, aluminium, it is conductive. It's actually a very good conductive material, aluminum is. So I'm going to button this back up together and test out that button, and everything should be good. And there you have it. So a little bonus interlude, way to repair a carbon pad with aluminum foil, working just fine now. hindsight 2020, probably should have used an accelerant and all that super glue when I put it in before putting it all together, so those fumes weren't staying inside and wrecking a little bit of havoc. But that's okay. Now back to the end of this video. Yeah, and it resets it. That's good. I will say, with this one, not a big fan of where the reset's located. Also, because that little graphite plunger, if you can see in there, in the edge right here, it sits on top of that screw, which is, you know, puts a little bit of a rise off of the board, and so that makes this thing sit at a very weird angle. I think that was not well thought through. It only needed to move 1, maybe 2 more millimeters that direction, and there's plenty of space on the board that could have easily been done. But well, this one ends part 2 of these Tamagotchi style repairs, and we've got 3 more left to repair, and we'll be done with this series. So if you enjoyed the video, give it a big thumbs up, like, subscribe, and share. Of course, as I always say, you don't have to, but I do appreciate it. Thank you for watching. Take care. Bye.